Hello students, welcome to Fly with Physics. In this lecture we will be discussing about the concept of force here, the complete concept of force here. Okay, so now let's get started. First of all, what is the meaning of force? The definition of force is it is the push or pull which can change the state of motion of an object. If any object is there and we can just change their state, then we can say that the force is applied on that object. Okay, how do we measure that there is a change in state of motion? So the change in state of motion can be represented by the change in velocity. Okay, change in velocity can confirm that there is a change in state of motion. Okay, so we can say that the force can change the velocity as well. Okay, for example, if a body is at rest, then we apply the force and then it attains some velocity. So here the velocity is change. uh, One another example also, for example, there is an object and then what will happen, and then the force is applied on that, and the speed of the body is changed, and so it means that the force is applied on that body. Okay, so there is a state of motion and v is the important factor here. Okay, so all the forces of nature are classified in actually four fundamental categories. There are four fundamental categories where the forces are classified. So let us see now. Now first category is electromagnetic force. Okay, the second is gravitational force. Third one is all the strong forces, and fourth one is all the weak forces. Now broadly we can say that these two forces are the long range forces. Why? Because these forces acts on a two body when they are in a long gap also. Okay, but in the case of these two forces are known as the short range forces. Why? Because they comes in picture only when the two bodies are in very close contact with each other. So that we can say that there are some forces like strong and weak forces. Actually the range for these strong and weak forces are of the order of 10 raised to power minus 12 meter, or in some cases there are 10 raised to power minus 15 meter. It means that if two bodies are in 10 raised to power minus 12 meters apart, or less than 10 raised to power minus 12 meter, then there are some forces acting on that you say masses, that both masses, and these forces are not electromagnetic and gravitational. They are maybe strong forces or they are maybe weak forces. They are also known as nuclear forces as well. Okay, nuclear forces as well. So now we will discuss the next topic. We say that the relative strength of these fundamental forces. For example, we have two particles, one this and one this, and for a given pair of particle, how much how these forces act from weaker to strongest. Okay, now we will see. For example, this is a body having mass m1, this is a body having mass m2. So first of all, gravitational force is acting. Okay, and gravitational force we may just you say take it as a reference. Okay, we may take it as a reference. So this is the reference for our comparison. Now see, then after that weak forces are there. Okay, then after that weak forces are the stronger, then after that electromagnetic forces are stronger, and then after that strong forces are stronger. Now if we see that how much extent the weak forces are stronger, so it is actually 10 raised to power 35 times stronger than gravitational force. And then if we talk about the electromagnetic force, obviously these are larger, and strong forces, obviously these are larger. Okay, so this is the pattern. First of all, gravitational forces, then weak forces, then electromagnetic forces, and then strong forces. Force can change the state of a motion, as we have already discussed, but we also know that we can apply the force in horizontal direction and vertical direction. So the question is that if there is any change, if we apply the force in the horizontal direction, or if we apply the force in vertical direction. So the answer is yes. If we apply the force in horizontal direction, then we can say that there is a change in the magnitude of velocity here. See this is the object and the force is applied in that direction. So object is already moving with velocity v. So when the force is applied, so there is a change in velocity, and we can say that the velocity increases when the force is applied in the direction of velocity. Okay, so when the force is applied, when the force is parallel to the direction of v, we can say that the velocity will increase and there is a change in magnitude of velocity. Okay, but what about when we apply the force in perpendicular direction to the velocity? Then what we can conclude that then we can say that for a body which is moving horizontally in that direction, v direction, then we can say that if the force is acting like perpendicular with the velocity, then we can say that there is a change in direction. The body will fall like that, like this direction, this trajectory will the body will follow. Okay, so the body will go here. If there is no ground here, just it is in air, so if it is moving like that, and then after applying this force, the body will move like that. So here what happens, here not the magnitude is changing, here the direction is changing. Okay, so when we apply the force in perpendicular direction, the direction of the force the direction of the velocity will be changed, and in that case the velocity's magnitude is changed. Okay, so there is a difference between the parallel force and perpendicular force when acting on a body. Okay, now moving to the next. Now we can classify the forces. Okay, the group of forces. For example, if an object there are some forces acting on the body, like in many directions, group of forces are acting on the body, then we can just broadly classify into two categories. First one is balanced force and the second one is unbalanced force. Now what do you mean by balanced force? Balanced forces are those forces in which all the forces that is acting on a body having the sum or whole sum is equal to 0, then we can say that this force is balanced. For example, we are applying 5 Newton here, 5 Newton here, 5 Newton from that side, 5 Newton from that side, and from that side. So all of these forces are cancelled by each other. This forces cancels this effect, this forces cancel this effect, because they are equal and opposite. Yes. Okay, so that is why the if we sum out all the forces, then it will be 0 at all. So that is why we can say that this body will not move at all. Okay, if this body is at rest, initially it at rest, then it remains at rest, and if it is doing some uniform motion, then it will remain doing in your uniform motion, although all the forces are acting, but their sum is whole equal to 0. Now just analyze this statement, f is equal to 0. So it also means that acceleration is equal to 0. How? Because in earlier classes we have read the formula f is equal to ma. So f is proportional to a. So if this one equal to 0, then this one is also equal to 0. So acceleration is also equal to 0. This implies that velocity is constant, because acceleration is equal to rate of change of velocity, and this rate is equal to constant. So constant velocity means the object may be at rest or may be moving with the uniform motion. Okay, so this is the case. I hope you have understood the meaning of balanced forces. Now talking to the unbalanced forces, which is just opposite to the balanced force. In that case, what will happen? In that case, we have a force here, and the sum of forces are not equal to 0 at all. Okay, here we can say that if the body is there and then some forces are acting, so their sum is not equal to 0. For example, if this much is, for example, 7 Newton, then the sum may not equal to 0. So this is the case for unbalanced forces. So the unbalanced forces, velocity changes, velocity may not be constant, velocity changes. And then if we talk about the acceleration, then the acceleration part is equal to summation of f by m. Okay, so there is some acceleration, there is some velocity, and the velocity keeps on changing at all. ठीक है, next one, the last one is Lami's theorem. Now when a body is under the state of equilibrium, for example this is a body and it is under the state of equilibrium. Equilibrium means there it attains their original state. If it is at rest, then it remains at rest. Okay, so this is the state of equilibrium. In the if any body is there and the three forces acting on this body, for example this much force F1 is acting on this body, this much force F2 is acting on this body, and this much force F3 is acting on this body. Okay, so these three forces are acting on a body such that if we take these forces and able to make the triangle like that, F1 is there, F2 is there, F3 is there, then Lami's theorem will be applied. How? What do you mean by Lami's theorem? Lami's theorem means, for example, if we are talking about the angle between F1 and F2, for example, this one becomes theta 1, sorry, this one becomes just a minute, if we extend this becomes F2, angle between F2 and F3. Now see, angle between F2 and F2 and F3, this is theta 1. Okay, this is theta 1. Similarly this much angle, this much angle, this much angle, and this much angle, this much angle, just a minute, something become wrong here. Yes, this much angle, yes, this is F1 and F2. Okay, just a minute. We can simply say that if this is theta 1, that this is pi minus theta 1, and if we talk about F3, then this one becomes pi minus theta 3, that just a minute, pi minus theta 3, and this one becomes pi minus theta 2. How? If we extend F1 here, then this one becomes theta 2, and if we extend F2 here, then this one becomes theta 3. Okay, so so these are the angles between the F1 and F3, F2 and F3, and F1 and F2 in this triangle. So if we apply the sine rule here, which rule? Sine rule in this triangle. So we can easily state that F1 upon sine theta 1, F2 upon sine theta 2, and F3 upon sine theta 3. If you want to remember this, then you just remember the you say this trick. Okay, so what is this trick? Just F1 theta 1 is there, F2 theta 2 is there, F3 theta 3 is there. Okay, so you just remember that for F3 this is theta 3, for F1 this is theta 1, F2 theta 2. So just put F1, F2, F3, and in the lower in the denominator there will be theta 1, theta 2, and theta 3, sin theta 1, sin theta 2, and sin theta 3. Okay, so you have to remember this, and this is very useful for numerical as well. So this is the introduction of force, and in the next lectures we will be discussing about the Newton's laws of motion as well. So if you like this session, please like this session, and then please subscribe my channel if you feel comfortable. Thank you very much.